right, so quick video on atomic mass units and grams and what the difference in the two are, why we use grams, and just a little further clarification from last year. So, as you probably remember, when we did average atomic mass last year, we did talk about the fact that the masses on the periodic table are given in AMU. Now, we really didn't go into any details, so just some brief history to kind of help you understand the difference. So John Dalton suggested the ability to relate different masses of different elements using this thing called the AMU, the atomic mass unit. And he initially used 1/16 the mass of an oxygen atom as the standard. So you would just compare things to oxygen. So hydrogen, which is 1 AMU, is 16 times lighter than oxygen. If you look at the periodic table and you find number 32, that would be germanium. Germanium is roughly twice as heavy as oxygen. And so for a long time, that was the way masses of elements were described. And they were literally describing the mass of the atom, right? A singular atom. That worked great and fine until they discovered isotopes. So since isotopes have different numbers of neutrons in the nucleus, that can change the mass of a single atom of an element ever so slightly. And this led to confusion over which isotope of oxygen they were supposed to use as the standard. In 1961, IUPAC, which is the International Union of Pure and Applied Chemistry, they're like the people in charge of chemistry as a discipline. They met, and in order to just get rid of the confusion and everything, they decided to redefine what an AMU was. So now, as of today, an AMU is 1/12 the mass of a carbon-12 atom. I mean, the carbon-12 part is important because that's the specific isotope that we use, okay? Now, when they did this, they adopted the abbreviation U, like lowercase u, as the unit. That stood for the UAMU, with the U, this one, the first U, being the Unified Atomic Mass Unit. But they didn't mandate it. It wasn't universally adopted. And people still use AMUs and DA for Daltons as a unit as well. So UAMU, UAMU, DA are all the same unit, all right? In our class, we'll use AMU for simplicity. Now, when people say AMU today, what they really mean is the UAMU, the Universal Atomic Mass Unit. And just keep in mind, from a sig fig standard, carbon-12 is defined as exactly 12 AMU, so that 12 is infinitely significant, all right? Now, you can convert back and forth between grams and AMUs. When you guys did average atomic mass, I told you, like, yeah, the answer is in AMUs, but we kind of just convert that over into grams per mole. And the reason for that is a simplicity thing, all right? If you look at, say, oxygen, for example, and we have 15.999 grams of oxygen in a mole. Well, we could convert that over to AMU. It's a big number, right? So, I mean, most of you guys can probably just look at that and go, all right, well, 1 gram, 6.02214 times 10 to the 23rd AMUs, right? And grams is going to cancel, and that leaves me with AMUs per mole. I mean, if I actually punch that into my calculator, I get 9.635, roughly rounded, times 10 to the 24th AMU for 1 mole of oxygen. And that's an annoying number to use in a calculation, right? Because when I sit something on the scale in my lab, it comes up in grams. So you don't need to memorize these conversions. The point is just to show you that, you know, AMU measures 1 atom, and that would be, you know, really difficult to kind of utilize in our regular calculations, all right? But now you know, all right, that is the difference in AMUs and grams. Now you know where they come from. Now you know how we use them. We'll see them a couple times in AP Chem, but again, you don't need to memorize these two conversions. Just keep them in your brain, all right? Now, that's all for this, just a little short thing, just to kind of help you guys out. If you have questions, shoot me an email, and I'll be glad to help you out.